A problem from the last quiz. A vertical spring hung 0.35 meters long. A vertically hung 0.35 meter long spring is stretched from its equilibrium position to a length of 1.1 meters by a weight attached to it. If 18 joules of elastic potential energy is stored in the spring, what is the mass of the attached weight? Okay, so the first thing, guys, is you really should draw pictures, label variables. So, guys, really do what I do. So, real quick, we've got an L1, or this is our length at equilibrium, and it's going to be 0.35 meters. Okay, I've labeled my first variable. Now my second one right here, this is a new length. I'm going to call it L2, and that's going to be 1.1 meter. Now, in springs, we need to also draw a picture. Well, let's actually just label everything too. So we're going to have potential energy stored in the spring equal to 18 joules. So I've done my first thing. I've gotten all my variables. I took this from here. This is the first length. Then it changes to this new length. And here's the energy. Now, this is when it's at equilibrium. So this is important. This is an extremely important situation because that's when it's at equilibrium, no energy is actually stored in it. So when it stretches to this new length and we have new energy stored in it, the elongation is the storage of this energy. Okay, so we look at this picture, and this picture is very important. Here we have the unattached spring, and then we have this weight. Now, the next thing I really want to highlight is this, that making anything into a free body diagram is a great idea. And once you've got this drawing done, you should realize that from this point, gravity pulls you down, or pulls this weight down, and something pulls up, and what pulls this up is the spring force. And these two are equal but opposite. So we can start off by saying this. I'm going to write them apart, and then I'm going to bring them together. Fg equals mg, and then also Fs equals, I'm going the wrong direction, kx. Now in this case, guys, these things are equal but opposite. So the force of gravity goes down, and the force of gravity goes up, or the spring force goes up. So this one's going to be a positive. So they're gonna be like this. You're going to say this: Fs equals negative Fg, because they're in opposite directions. So this is naturally a negative value, but when you multiply by negative, it'll make it a positive. Okay, so let's get rid of this, and now you're going to see why I did this drawing right here, because I'm gonna bring these. Hopefully, I can click on them and move it. I'm going to bring this right here, and now these things are equal. But I've got to do my enhancement like I was talking about. So I'm going to set these equal. I don't know why I changed those colors, but great. Let's look over here. So now what we'll see is this. These things are equal, but this is negative and this is negative to make these positives. Okay, so now we can cancel things out, and make an easier formula. This cancels out, or this cancels out. And why they cancel out, it doesn't really matter, because I only care about these two things. I'm going to say kx equals negative mg. These things in the middle, the forces don't matter. What I'm looking for is the mass. So now I can say is this: kx equals m over negative g. All right, you may say, well, Mr. Shaw, what have we successfully accomplished here? We have a formula you've written for the mass. We do know x. Well, we can find x in a second. The spring constant, that's something we don't know. We do know g, so these are two things we don't know. Let's go back over here, guys, and we'll take a look. Now remember, x is the difference between these lengths. So make sure you've got this formula written down, because I'm clearing off my screen. So x is this length of elongation. This is x. So how could we find that value? Well, remember I called this in the other page L2 and L1. So I'm just going to do this. I'm having little problems here. Sorry, guys. L2 minus L1 is going to equal x. And you can just do that on your own. That's a very simple calculation to do. Okay, so you've got that down. Now let's go back over here, because we don't have k, but we do have this. You should know this formula. PES equals 1/2 kx squared. Plug in your x, plug in 18, and solve for k. And then go back to that formula with these values and solve it. Make sure, guys, you wrote everything down. And this should be something very simple to solve. Algebra from here on out.